In section 8.1, we're going to talk about solving systems by graphing. So to start, two or more linear equations form a system of linear equations. Sometimes we'll abbreviate to SLEs. Any ordered pair that makes all the equations in a system true is called a solution of a system of linear equations. And what that looks like on a graph is where those lines intersect. So in example number 1, I want to know what is the solution of the system y equals x plus 2 and y equals 3x minus 2. Now there is an algebraic way that we could solve these, and we're going to learn about that in the next couple sections. But for now, let's graph them and find the solution. So y equals x plus 2 for graphing by hand. These are both in slope-intercept, which makes them relatively easy. My y-intercept is 0, 2, so I'm going to start there. And then my slope is 1, meaning I'm going to move up 1 over 1. So I'm going to count up 1 over 1 each time, keep them work backwards and go down 1, left 1, and then I'll make my line. The line y equals 3x minus 2 starts at negative 0, negative 2 for the y-intercept, and then my slope is 3, meaning I'm moving up 3 over 1. So we'll start at 0, negative 2, count up 3 over 1, up 3 over 1, up 3 over 1, and then I'll make my line. So here I can see that that's my solution. So my solution to that equation is the coordinate 2, 4. And if I wanted to check that, I could plug in 2, 4 for both equations and see that they make both the equations true. So what I mean by that, wherever I see an x, I'm going to replace it 2, and wherever I see a y, I'm going to replace with a 4. And we'll see here, to simplify the first equation, 4 equals 2 plus 2, or 4 equals 4, so that equation's true. And then in the second equation, we have 3 times 2 minus 2, which is 6 minus 2, which also gives us 4. So the solution 2, 4 makes both of those equations true. In example number 2, you and your friend get jobs as lifeguards at 2 different pools. Pool 1 offers an $8 starting hourly wage with a $1.50 pay raise every summer. Pool 2 offers a $10 an hour starting hourly wage with a $1 pay raise every summer. And I want to know, after how many summers will you and your friend be earning the same wage, and what will that wage be? So the easiest way to do that is, again, to make a system of equations and then graph it. So to make an equation for Pool 1, we're starting with an $8 an hour wage, and then we're adding a $1.50 to that wage every summer. So I'll do y equals 8 plus 1.5x, x representing number of summers, y representing your hourly wage. For Pool 2, we start with $10 an hour, and then we're adding a dollar every summer. Now after we have our two equations and also 1x, we could just write as x. Now, we'll just use Desmos to type out our equations, and then I'll see a picture that looks like this for my solution. So I see that I have a solution at 4, 14, so how I can interpret that for a word problem. After 4 summers, you'll both be earning $14 an hour. Now let's say instead of offering a $1.50 wage pay raise, Pool 1 was only going to be offering a $1 pay raise every summer. Now with this new information, I still want to know after how many summers will you both be earning the same wage. So now, instead of Pool 1 having that equation, I'm going to change 1.5x to 1x because I'm only adding a dollar each summer now. Pool 2 stays the same, and now if I graph both of these, again, I could use Desmos or I could just go by hand. Pool 1, I start at 8, and I'm counting up 1 over 1 and making my line. Pool 2, I start at 10, and then I'm counting up 1 over 1 and making my line. And what's weird about that is even if I zoom out on my graph or zoom in, there's never going to be an intersection point because these lines are parallel. Now, before I even graph this, I can know that they're parallel because they have the same slope, and that's always going to indicate that two lines are parallel. But what's interesting here is that they're never going to cross, so there's going to be no solution. So in this situation, you and your friend would never be making the same amount of money no matter how much time has passed. So that's going to conclude to the types of solutions that we'll get with systems of linear equations. If the lines cross, you have one solution. If the lines are parallel or they don't cross, you have no solutions. And then finally, the one we haven't talked about, if you have a line and then another line on top of it, basically meaning they're just the same line, we would say that's infinitely many solutions.